Hello everyone. Welcome to the AI in Practice podcast. I am very excited for this episode. I really wanted to name it Building Smarter Apps, but I'm joined today with Shadi Fanous, who is very detail oriented, and he completely refused the name and he wanted to name it Building Machine Learning Applications.
You're
We
making
had
me seem like
a
a bad
heated
guy.
debate, a very heated debate, where he actually won. And this is why we call this episode Building Machine Learning Applications. So I'm joined today with Shadi Fanous, who's our CTO. Shadi has been deploying machine learning algorithms for the past 5 years. He has been CTO of Synapse Analytics since its inception, and he is the man behind all of our products, from our MLOps product to our computer vision product and all of our deployments. Shadi has been a major he is the backbone of Synapse Analytics, and I'm very excited to have you on today. Hi, Shadi.
Hi, Ahmed. Thank you for having me. And thank you for the introduction.
Yeah, sure. So actually, one of the things that I have to mention is Shadi. Some of our audience are not from an Arab background, and they always are very curious about his name because his name is Shadi Fanous, and people usually read his name Shadi Famous, which is a rapper's name.
Yeah.
And everybody gets excited and everybody wants his autograph, but at the end of the day we just tell him he's just your above average CTO.
Joke, yeah.
So
Yeah.
Hi Shadi, and are you ready for today's episode?
Let's get going.
Let's get going. So today's main topic is about how to build machine learning applications. Now machine learning, software is getting more sophisticated by the day, and integrating machine learning in software is becoming more and more a priority for software developers, for startups, for big tech. Everybody is speaking about how to get machine learning into their applications and power their software. So my first question is, because I think you are one of the people who always told us, guys, not anything can use machine learning. You don't use machine learning for everything. So
That's true.
My first question is how to frame and evaluate that this is an application where you actually need machine learning and need AI.
No, okay. I think that's a good question because at the end of the day, when you look at the problems that are are you laughing?
I have a big cup.
Yeah, Darth
Lord
Vader.
Vader.
Yes.
I saw it in your eyes. You wanted to laugh, so I'm sorry. So how do you frame and evaluate if this is a use case where machine learning is needed?
Well, yeah, I think it depends on what you're trying to solve. So before machine learning, we used to solve a lot of problems without machine learning, but some of them were good, some of them were bad. So take, for example, classification of images. So back in the day when we wanted to classify giraffes, for example, we would essentially check for the color yellow.
Yeah.
But then again, this
can
brings
have a lot
out
of variability.
false positives, and it's not that efficient. But once machine learning comes in, it actually simplifies all of these problems. So usually what I use as a metric is if the problem is linearly solvable, then you can probably come up with an equation that can
come up with the
solve.
logic to solve it.
Yeah, exactly. If it's not, if it depends on a lot of inputs and there's a lot of probabilities of different outputs, then you probably need a machine learning algorithm to try and find these patterns and solve the problem for you.
So maybe it has to do with the variability of the solution itself. So if the logic can expand through a lot of variable, requires a lot of there's a lot of variability in the output, then maybe machine learning is useful.
I think maybe we can frame it in a different way. The solution of any problem, or let's say most problems, is an equation.
Yeah.
If you can figure out this equation, you can essentially solve it without machine learning.
Very well put, my friend. So as you can see, today I have actually my iPad because our editors, and a big shout out, by the way, to Schema for prepping us up with the best equipment in the business. And they told me that I have to actually prepare. So I actually prepared the questions, and I have the questions in front of me. So to make it easier for the editors, instead of just improvising my questions, for the host,
Sure,
for
sure.
the guest.
Yeah.
So, Shady, now a lot of our customers at Synapse, usually we talk with them, and initially they tell us that they're actually using machine learning and they're using
Mhm.
AI.
Mhm.
Now, once we dig a little bit deeper, we see that the AI is not actually live.
Mhm.
It's just running in the background, and it's not
Nobody's
actually.
taking care of it. Yeah.
Yeah. So, how do you classify a live? So, what is a live model? How do you,
Mhm.
you know, say that this is a live
They're
model
actually
in
using
production?
the machine
Yes.
learning.
Yeah.
So yeah. Well, I think there's three ways of using machine learning. So there's the one-off way of using a machine learning algorithm. So if you have someone that did a machine learning algorithm and he's just going to use it for just a one-time thing offline in a Jupyter notebook or in a script, and he gets the results, and then that's it. So that's one way of using machine learning. It's probably not the ideal scenario. It's probably not as sophisticated, but it's a valid use case for machine learning.
But it's very much in vacuum, right? So it doesn't talk to systems. It doesn't.
No, it's
yeah.
just a script. It's a script that takes inputs and gives you outputs. A one-time thing.
Yeah.
Nobody looks at it again.
So a good example of that, maybe you want to optimize, for example, the location of your warehouses, and this is like something that you do once every 5 years. So you just
exactly.
Yeah.
A
Okay.
simpler example: if you have a bunch of images that you want to classify, for example, they're in your database or they're in somewhere else. So you just run the script one time. You don't have to see the script again.
Okay.
So yeah, that's one way. The second way is using the machine learning algorithm as a background job,
Yeah.
or it's sometimes referred to as being ran in a cron job. A cron job is basically a scheduled task.
Okay.
So essentially, the machine learning algorithm would run once every day or every month or every year or whatever.
But it speaks to systems, so it takes input from different systems and it outputs the results to different systems as well.
Yeah. So yeah, it's the responsibility of the machine learning algorithm then would be to speak to databases, warehouses, and so on, get the useful data that it wants, and output the prediction that it does in whatever format or place that it needs to place it. So that's the second way. The third way, and probably the most sophisticated way, is to have the machine learning model as a live web service or as a web service. So essentially, this would be a web server in your infrastructure that has APIs that you can connect to it. So at any point in time, you can connect to the model, say I want to predict X, Y, and Z, and I'll give you the output instantaneously.
Yeah.
So yeah, these are all the three formats. So
I think most of AI builders or AI users usually are in the first two categories, and I think a very, very little number amount of people are using it
as
live,
a web service.
as a web service. Yeah,
because it's sophisticated. It needs a lot of work, but once it's done, like it helps a ton with.
Yeah, of course.
Like if you want to move the machinery, you can move it easily because it's not as dependent on other systems because it has APIs. There's also the fact that you can update it as easily and keep track of it as easily. So, but yeah, it takes a lot of work to get to that stage.
What does it usually take to successfully adopt artificial intelligence in your applications? In whatever form they might be.
I think the most important thing is to have everybody on board. Machine learning is an extremely new field. There's not a lot of people that understand it. There's a lot of misconception in the wild about what it does, what it's capable of, and there's a lot of false hopes that are on the internet as well. But I think first and foremost you have to have like a session or a meeting that describes what we're trying to do, how machine learning will help, what it can do, and what it cannot do.
So stakeholder alignment, basically.
Exactly, yeah. Because if you mention machine learning to a stakeholder, it's for them, they read all about it online. So for them, it's a magical recipe that will solve everything. while in reality, machine learning is just a small piece of the puzzle,
Yeah.
which eventually embeds in a typical software engineering program.
Yeah.
So
So
yeah.
actually, I think one of the things, when you were speaking about the stakeholders meeting, for example, if you're going to apply machine learning to basically give dynamic promos to your customers, sometimes the marketing is not really trustful of your
Mhm.
algorithm. And sometimes, the business, especially business people, are very much looking into the one mistake that the ML model would
Mhm.
make, and then they wouldn't trust AI.
Mhm.
Again, you remember the Uber incident where I think, I'm not sure if it's Uber, just not to,
Mhm.
but I think one of the companies had an autonomous driving vehicle that hit someone, and
I think that's Tesla.
that's Tesla. Yeah, Tesla. So sorry, Uber, it wasn't you.
I think the footage was in the night, if I remember correctly. It was,
maybe, and everyone just completely focused on this incident, and they said that autonomous vehicles is a false promise, autonomous driving is a false promise, and so on. So
Mhm.
how do you actually, what does it take to really create trust between the users or the internal users, maybe even, and the AI?
Well, I think we need to bridge the gap
Mm.
between the data scientist that does the models and the business users
Yeah.
that are actually use the models at the end of the day.
Mm.
So how you bridge the gap is through, for example, explainability of the models. So you'd have, like for each prediction that it does, you would actually have a layer that explains why the machine learning model picked that. You'd actually have, for example, any sort of dashboards that are automatically updated to reflect the accuracy and the precision and whatever other metrics that are business specific to the model. So you need to have a lot of monitoring and observability on the model. So number one, to ensure that it doesn't go bad for whatever reason.
Yeah.
Number two, to build that trust.
Yeah. So you actually you went into my next question because I
Okay.
prepared very, very well for this episode.
I'm sure you did.
So yeah, so the AI, AI has a very specific life cycle, and it's
Mhm.
different than any, DevOps operations.
Mhm.
And so DevOps operations is kind of an oxymoron, but that's fine.
Sure.
So yeah, so it's different from any like traditional software life cycle. So
Yeah.
how does it differ? How does the AI life cycle, managing AI in production, is different from just managing traditional software?
Yeah, you're talking about the management part, not the development part.
The management mainly, yeah.
The management. Well, okay, they're similar,
Yeah.
but when you're dealing with machine learning, there's a lot of extra stuff that you need to do.
Yeah.
So there's certain terms of you need to have monitoring and observability in place. So you need to
Yeah.
actually know.
So what do you
understand.
observe exactly in machine learning?
Well, in machine learning, you observe any business metrics that you need. So, for example, how the model performs on a day-to-day basis in terms of accuracy, in terms of precision, recall, error rates, and so on. For example, if you're doing a credit scoring solution, for example, you'd monitor the ratio of acceptance versus rejection. That's an example of a business metric that you need to monitor. So that's when it comes to monitoring and observability.
So business monitoring.
Yeah.
So business KPI monitoring, basically.
Business KPI monitoring.
Yeah.
So what the question again was?
So what do you need to monitor when it comes to AI in production?
So that's essentially it. The question before that, what was it? How would you?
So
what's the difference
how
between?
is AI in production, managing AI in production, different from managing traditional software?
Sure. Okay. So another difference is once you have that monitoring in place, so now you need to actually.
So did you hear my daughter crying in the background? So that's fine. Okay.
Yes.
So okay,
ولا؟
خلينا أعيد الحتة دي.
ماشي.
So how does managing AI in production differs from managing traditional software in production?
So once you have all the monitoring and observability in place, the difference between a typical software program and a machine learning program is it doesn't depend only on code. So you can imagine that software applications depend on code.
Yeah.
machine learning applications depend on both code and data.
Yeah.
So since the code is fixed, like
Yeah.
we've deployed the model, it's done, the code doesn't change. The problem is with the data that keeps coming into the model.
Yeah.
So eventually there's gonna be shifts or drifts in this data. So we need to actually monitor any data drifts that happen. We need to actually monitor if the model degrades in quality. So you monitor the inputs, you monitor the outputs of the model as well. If they differ from what the model was trained on, then you need to actually retrain the model to be able to accommodate these actual changes.
So what do you mean by data drift exactly?
Data drift. Okay, so let's assume if I'm, for example, training a model to predict the price of houses, and the output that it gives off is in, for example, euros. For example, right now, as of this podcast or when it goes live, the price of the euro has gone down.
Yeah.
So I actually trained the model on a certain range of prices, but now it's actually gone down.
Yeah.
So this is an example of data drift. I've trained
Okay.
my model using a set number of
On
set of features.
certain facts of the world,
reality,
and then
yeah.
it changed. So
But that changed.
probably the model will be confused in.
It'll probably give
Yeah.
a higher output than it's supposed to do. So we need to actually retrain to be able to accommodate this change.
What are the main showstoppers when it comes to launching a machine learning powered application? So what happens? How would you? What are maybe the checklists that you have to approve to say that this is ready to market and we can go to market with this architecture or this piece of
You need a data
application?
ingestion pipeline.
Okay.
You need tools and monitoring or observability tools in place to be able to see if the machine learning model is actually working correctly or not.
Yeah.
So if you deploy the model without observability on it, it doesn't make sense. It's gonna go bad. You just don't know when.
Yeah. And I
So-
think you need to observe the right things as well.
You need to observe the right things as well.
Yeah.
You need to be able to have a pipeline to retrain these models once they go bad, because they will go bad eventually.
Yeah.
And you also need to familiarize the people that are using these models that, hey, this is a model, this machine learning model doesn't mean it's 100% accurate. There's a certain range or threshold of error that you've taken into account.
Yes,
that you've taken into account, and you know that it's gonna be there. So you need to actually monitor whatever goes on.
Yeah. So Shady, one of the main benefits of launching a machine learning application is that it gets smarter with time.
Yeah.
How do you make sure that this happens actually? So how do you make sure that your machine learning is getting smarter and your application is getting smarter, it's getting more adaptable?
Sure. So well, it doesn't get smarter by itself. Like you need to have a feedback loop in place.
Okay.
So you need to actually provide the model what the actual ground truth. So let's say, so for example, if the model predicted that the price of a house is $5, if the actual price is 10, you need to give the machine learning model the actual price back to it again.
Yeah.
So once you have that pipeline in place, you'd have continuous retraining on the model so that it would essentially adapt to the new data that keeps coming in.
Yeah. So, and there are, I think, maybe milestones in which you need to stop and retrain the model.
Well, yeah. So for example, take the main metric that you're focusing on or that you want to optimize. So let's say, for example, that's accuracy. If your acceptance criteria for that accuracy is to be not below 70%, for example. So once it reaches 70%, you need to retrain on the new data in hopes that it actually goes above the 70 to an acceptable range.
Yeah, sometimes I've heard one time from one of the data scientists working in telecos. She actually told me that sometimes it takes 6 weeks to retrain a model.
Yeah.
Why do you think that is?
Well, I say they don't have a proper feedback pipeline in place.
Yeah.
So there's no way So to be able to actually retrain a model, what they would do is actually do the training job all over. So that would take essentially the whatever amount of months they do it in.
Yeah. So maybe, getting smarter is not just by retraining. Sometimes you could, for example, maybe deploy like shadow models that could be tested against your model in production, for example. Is that something that is like is this like common nature in building machine learning applications?
It's an advanced technique because doing that in the traditional way. So for example, if I have two models, I want to deploy the two right next to each other, and they both take the same inputs and give out the outputs, but one of them is actually the one that's being given back to the user or given back to the system that's actually critical to the infrastructure. That requires a lot of engineering. So you could go into dependency hell. You could go into setting up another infrastructure for the other model. You'd actually have to always keep track of which version is now live, which version is now in the background. So there's a lot of hectic work that needs to be done. So if you're not using a tool, obviously.
So it's great that you mentioned infrastructure, because a lot of our calls, people are actually maybe if you have like 3-4 data scientists in your team, it's not a big issue. But I think one of our prospects that we were talking to said that, guys, this is becoming a burden, just setting up infrastructure. Why is it that difficult to set up infrastructure when it comes to machine learning?
Well, there's two ways to set up an infrastructure. One way is to have it on-prem on a bare metal machine. So you'd have a server sitting in your back office, and that's running 24/7. But the problem with that is it's prone to electricity cuts, internet outages. Someone could go into the office and turn it off. So that doesn't actually make sense. The next step would actually, you take this server and put it in a data center. So they would actually take care of it. And that's a valid solution. The other solution that I think most companies are now moving towards, if they're not already using, is using a cloud provider. So I'm going to mention the three big names, which are AWS, Google, and Azure. Microsoft. So what people usually do is they get a machine from one of these providers and they put their models on. But the problem with using these providers is you're essentially, number one, you're going to be locked into whatever, you're going to be locked into their environment. Number two, you need to actually know a lot of very specific details about each of these providers so you actually use them efficiently. So they have a lot of SKUs that they sell. They have a lot of services that they sell. Some they manage, some you manage. There's a lot of hectic work. So you need someone that actually very familiar with these type of stuff. They would choose the right resources to get to deploy the models.
So one thing that, since you mentioned cloud providers, is one of the things that is going around in the market right now is basically auto machine learning, auto ML. And auto ML is, like everybody promises auto ML now. And, they sometimes they go to clients and tell them, guys, just, get your data on our cloud and we'll build you an automated credit scoring without even you thinking about it. Is that a realistic promise?
Well, it's valid. Well, I personally think that AutoML is great when you want to create a baseline model. But when you want to exceed or improve on the accuracies that the baseline model gets you, you need to actually have a data scientist or a machine learning engineer that sees what the models gets as inputs, tries to do manual feature engineering, tries to adjust it to improve that accuracy or the error metric. So So
maybe this is actually one of the things that I have issue with, maybe in some use cases it might be valid, it might be realistic, though maybe in other use, like demand forecasting, for example, because we did a lot of demand forecasting, and we really understand what it really takes to do the feature engineering. The feature engineering is really complicated. You need to go through a lot of missing data and unusable data, and systems that are legacy systems with old product numbering, and there is new product numbering, and everything is mixed together in a spaghetti kind of data lake of sorts. And
okay.
and
You're talking about data now.
So the I think one of the art in modeling usually is in the feature engineering and the feature selection, and how you build your how you do how do you bring out the necessary features out of all of this chaos to bring it to a model that is able to correctly predict. And,
let me say that, let's say 95% of the cases, changing the model would do little to improve whatever metric you're monitoring. The major change comes from changing or improving the actual data.
Shady, now this is a question that I ask every guest.
Okay.
What are you most excited for in the AI field right now?
I think people are realizing that developing machine learning models is not that hard. It's actually very accessible right now. Like if you have the data, you can create the model for it. I think the main problem challenges that people are noticing right now is getting this model into a usable state that is comparable to the usable state we have for traditional software programs right now. So the deployment of the models is actually what I think is the hard part, because a lot of people that studied computer science or computer engineering, what usually they study the software, the paradigms around software engineering. But when it comes to machine learning and development and their deployment, there's a lot of extra skills that are required that maybe people are still not definitely not in universities, or they're not as mature in universities. Maybe a select few universities have reached that maturity. But people usually rely on external resources, either that's papers, Udacity courses, for example, and so on, to gain that knowledge. So there's a lot of work that still needs to be done by the community and by the people to easily deploy machine learning models, and there's a lot of work by people that create the models to be able to deploy them. So that's what's exciting.
So it's really great that since we work, of course, in the field of MLOps and machine learning operations, is that you and Gala are very much excited about deploying deploying machine learning. And
we've been deploying models for developing deploying models for 5 years. So we've seen the gap in
from a real pain. Shady, this was an absolute pleasure having you on the AI in Practice podcast.
Thank you for having me.
And looking forward to our next one. So
thank you.